Here is a nice little surface geometry question here from 2017. Okay, now if we have a little look through this, we've got a fairly straightforward plan elevation, and again at a glance here it seems to have all the measurements here, so this should be rather nice. Our good old friend the dihedral angles, and I'll talk about that along the way. And this part C is kind of where it gets a bit more interesting. Alright, and this is where we really want to focus on. If you are getting comfortable enough with the first two parts, this is the very interesting bit. Okay, and finally part D is actually not too bad. Okay, don't get too worried about that, and we'll come to it in time. Now, let's have a look at how to set up this question. First things first, this is a fairly big drawing on A3. All right. We were asked to draw this, the elevation, plan, a surface development. Let's say it goes approximately there, and we have a dihedral of A and B. So if I was to look this way, I'd have a construction here. Okay. This needs to be pretty near the top of the page. So let's have a think about our sizes. 1 to 6. Okay, well, what kind of measurements have we got here across the board? Well, that's pretty gigantic, isn't it? So let's say, 360 goes to 60. 120 goes to 20. 90 goes to 15. And now we're kind of getting the pattern here. Okay, 180. I normally like to try and do them in order, but you know, life isn't perfect. And that will be 30, and so on. Okay. Worth sketching these out just to get this bit of stress out of your head, and once you do this you can kind of see 240 is going to be between these two, and okay, it's 40. Alright, so we're going to sketch this out and let's see what our total sizes are. That 180 is going to be 30. This is 240 plus 120, so it's 360, so that is 60. And width-wise it's bloody big, isn't it? So this is kind of annoying to add up, so I'll add them up scaled, like that's 60, 15, 20, 15 and 60, so that's a little bit easier. Those two are 75, two of them is 150, and that is 170 the whole way across. Okay, so now I can kind of set this out and draw it. I'm only going to come 50 down from the top of the page because I want lots of space to draw this down here. So we'll put this right up here near the top, give or take, and there we go. Okay, so that's my little drawing. Make sure we're happily on here on camera. And let's see, it's going to be 170 long, so we'll stick it about there. Again, I'm biasing a little to the right. We won't go all the way to the right in case stuff happens. So there we go. Okay, so let's just go through our individual measurements here. So it was 60 across, and grab this where we can see it. Then 15, there it is, 75, then another 20, 95, then another 15, 100, 110, and then 60, there we are. Okay, so that's all good. We are going to be up by 30. So we'll just give ourselves a nice big construction here to measure everything off, and we'll come up by 30. Okay, 20mm gap, just nice and tidy, and we decided it was 60 long, so that's down to here. So now I can kind of draw out here the little boxes that this would sit in. Okay, so we just make sure we're all happily on camera. We are looking good. So let's get this plan elevation done. I haven't seen anything weird so far, so we won't get too worried about it. We come across this 20 line is the heavy line up. So again, we'll just project these to the plan at the same time. Need to pop that in heavy. Okay, that goes down there. That's a heavy line. That's not a heavy line, but do I have anything happening in the plan? Let's bring it down just in case. There we go, we'll bring this guy down. The nice thing about a drawing like this is it's symmetrical, so some things are going to be reasonably easy. Now that 15 does actually have to go up the top. There we go. Oops, sorry about that. Now, this point you're wondering, where is the catch? What is tricky in this drawing? It doesn't really come into part C. Okay, now I like to label stuff just so I know what I'm looking at, BAC. And we'll get out and see can we get these guys done. So we have a 60 here, which becomes 10. It's easier to measure on this side. So I'll pop those two little measurements in there, the two 60s. And certainly send this one across. Okay, and that one. Now I can begin to put some of my measurements in here. So these are my two little top rectangles, there and there. Now remember, you've got 35 minutes for these questions. We'll see how we're getting on at the end of this little bit here. But you're certainly picking up a lot of marks along the way. And sometimes the problem for some of you is going to be that this is so easy, you might rush and slip and make a little glitch. So you'll know yourselves if small details are harder than the big details. Just be careful when it's this easy. All right, what else we got here? We have surface A. It's just this little rectangular shape. Of course, it's sloping down. This is high and that's low. What else do we have? That is actually just a line straight across. Okay, happy days. Now, it fits nicely on my page. I've got loads of space down below for the development or for whatever else is going to happen. BAC, because when they ask me for the dihedral, I'm not going to make a little slip and suddenly get the wrong one. Okay, now our next bit is dihedral between A and B. Okay, so we'll look that way, it looks dead easy. Now, just to give you a little bit of an idea, so far we've got 14 marks out of 45. Okay, that's pretty damn good. What we're going to do is we're going to pick up another 18 on this dihedral. Now, a few of you have been asking us, what is the point of doing dihedral angles? Okay, and we could say, well, if you're doing, setting up a sheet bending machine, it would tell us what way to bend the metal and so on. But of course, you know, some of these things can be pulled out of SolidWorks. What I say is, in terms of the drawing, there's two kind of reasons it comes up a lot. One is that it shows a very good understanding of your ability to use auxiliary views, to work with true lengths and so on. Okay, so it's a very good test of some of your skills. It's also very examinable. All right, and it is difficult for them to avoid examining something that's so easily examinable. It's a lovely mid-level complexity. They can put it up regularly, so it's a great chance to show off a standard but complex piece of work. All right, I would say don't get too upset over this. The leaving cert is not perfect. DCG is better than most. And having spent most of my 5th year being rather pissed off at the whole system and the insanity behind it, you know, in the end of the day, you're still going to be examined on it. So don't get, I wouldn't be wasting time on this one. This is speaking as someone who did waste most of my 5th year on that one. It's examinable, it's learnable, there's loads of marks for it. Let's play the game and let's win the game. Okay, so we're going to look this way. All right, so my x1, y1 is parallel to the line of intersection, so we'll give it our unusual set of numbers. That's called 1 and 2. I'm dealing with surfaces A and B, so I need to take another point off each one. I will take that as 3, and I will take that as 4. Okay, so you can see it's going to give me my little sections here. I chose 3 because it's on the ground, and it's nice and easy to work with. And I chose 4. Get this different color. If I have a different color, I do. Because it's the same height as 1, okay, and I didn't want to be going all the way over there. It doesn't really matter. I would say don't introduce extra bits of heights. No point in making life hard. Okay, let's project across. Well, look, this 2 and 3 are even on the same line. Okay, so there we are. 2 and 3 are both on the ground, because that's 3, that's 2, that's 1, and that's 4. That's 2 and 3. Happy days. There is 1 is on this line, but it's a bit higher up. Now, I can use my compass, but I actually know that that's 30 high because I know it from the measurements beforehand. So we'll just take that height there. And it's going to be the same height for 4, so I can even project across. So that's 1. Okay, and just in case you weren't sure, that height is 30, which means this is 30. And let's send 4 across. I mean, as dihedrals go, this is about as easy as it's going to get at higher level. So happy days. Now, be a little bit careful. A is 1, or God, I even wrote that wrong, didn't I? A is 1, 2, 3. So this is surface A here. Happens to be a line. Grand. Doesn't matter. And surface B is 1, 4, 2. So it's this little bit here. So we'll just add this in. These are already intermediate constructions. I would say draw them heavy. It's easier to see what's going on. Okay. So there's auxiliary 1. Not so bad. Auxiliary 2, we are going to look along the line of intersection. Now I'm actually going to send this one up here because it looks like I have the space and I want to use the space down here for my development. Okay, so auxiliary 2, we are going to look along 1 to 2. Okay, 1, 2. Now let's see how big this is. This is actually pretty big, so I'm going to take a measuring line because I can see otherwise it's going to be probably off my page. Okay, instead I'll probably end up doing this across my drawing, so we'll fix that now. Look along 1, 2. Right, so that means x1, y1 is going to be perpendicular to this. So we'll just slide over here and throw in a perpendicular. Make sure we're still on camera. We are. x2, y2, because it's the second time round. I could have pulled that far further down. I just have my annotations in a bit of a mess. But I can also see that this is going to be fairly tight. So if we have a look at this here, I'm going to take a measuring line at 4. Okay, and again, take it at a point, save a little bit of work. So I'll take my measuring line there. All right, which means 4 is on the line. So let's go project up. Now I actually have 1, 2, and 3 all sorted out up there. This could be a problem, and I'll come back and address it if it is. Okay, so there is 4. All right, so 4 is on the line. 1, 2, and 3. Now let's see. 1 and 2 are here, so it's that distance apart. I know I did measure it, but I kind of forgotten what it is, so I'll just take my compass. Now I'm regretting using my compass, but hey, 1 and 2. So there we go. So that's point 1. That's point 4. These are 1 and 2. And 3 was up there, and I just remember we can do this. So that was actually 15 and 20. If I go back and look at my drawing, so 35 together. Okay, so you can see that here. That's going to be 35 mil, and I can just put the 35 mil down here. So it's just another way of doing it. There we go. And that is 0.3. So you can see that actually worked itself out just fine. Okay. There we go. Just like that. That's our dihedral. Now if I have a look at the time, I'm 14 minutes into this, and this is with me going on and on about the existential issues around the leaving cert. So it is, however, 14 minutes at 35, and you have 32 marks out of 40. Okay, so you're absolutely flying through this question. Now, I'll just give you an actual measurement of what that dihedral is, so you can compare it to your own. So let's extend that out there and there, so I can see it. And I am seeing that that's this line just here. So it's getting bigger, bigger, bigger. So it's 150, 5, 6, 7, 8. 158. Okay. Right, now that's all our fairly standard stuff. You're flying along at this stage. You've got a very nice set of marks. But what do we do next? Now, this I thought was actually slightly confusingly written. Okay. Determine the true length of the shortest diagonal on surface C. The two diagonals are there, and we'll give it a different color for this one, and there. Those are your diagonals, the ones that kind of cross over from the points. Okay. So the shortest one is obviously the blue one. So this is what we're going to do. Now let's have a think about this one. In real life, that is doing something like this. All right. So we need to try and see how can we see a true length of it. Well, there's several different ways we can do it. Okay. I would always try and rotate if I can before I do an auxiliary because it's a bit easier. So we're going to spin it around like that. Okay. Just spinning it around. Okay, about the point where my thumb is holding it. And of course, when we look this way, bring the camera up, look this way, you'll see the true length there, and that is our elevation. So that's the plan. Let's see what we have here. So we'll just pop that line again. I'll put that in blue just so we know what we're talking about. So that's the original. Okay, this is what we're trying to get the true length of. Okay. So let's rotate that. So it comes down to there. So now it's rotated and it's still going up. So looking down, I can't see a true length because this pointy end is higher than the bottom of it. But I can see it when I look in elevation. So we got to project that up here. Now, that's 3. Let's give this a name. Let's call this 5. Okay, so 5 is there, all right, but as it rotates, it just moves across. So imagine looking at the point here, as this rotates around, this point isn't going up or down, it's just moving around in plan, okay? But in elevation, we just see it go sideways. So it ends up being, we'll call this 5 dash. It ends up being here. Okay, so the true length is from 3 to 5 dash. We'll do this in a green so you can see it. Okay, and that is the true length. Okay, that's it there. Now we have that. Okay, now you might think, why do they do that? That seems kind of weird. Actually, they're being very nice and they're setting you up for the final step. Okay, because one of the key bits in this is drawing the development. And if you see these weird intermediate steps of true lengths, they're usually being nice. Okay, and we'll also realize the dihedral is a crucial part in that being nice. So, what are we asked to do? The true lengths of basically unfold the whole thing. And they're very nice. They give you an idea of what it looks like. Even a little reminder that we're going to use dashed lines to indicate folds. So let's do this. Now, I'll be honest, I would do this slightly differently in that I would orientate it straight down here. Okay, because I can project a few things down. Just not a big deal, but I can project a bit. So let's see what we can do. Now I have a decent bit of space. So let's project down here. Okay, sure we're fully on camera. Yep, let's scoot this up a little bit. And let's see, can we get A? So we'll just choose a point to start A, doesn't really matter, but I'm going to go somewhere in the middle. Okay, so there's the top of A. Now, it's all about true lengths, and this is where it's good practice. How long is 1 to 2 in reality? Well, it's not a true length there because it's a slope going up. It's like this. It's not a true length from the elevation for the same reason. But when we look at it from the side, and we have looked at it from the side, we can see it. So look at this. Right there is the true length of 1 to 2. Sweet. There it is. Scoot in here. Measure with your compass. Don't know what it is. Don't need to know. And there we are. Or you can just project across, but you get the idea. So this is now the development of A, the true shape of A. And again, some questions might ask it to you as a true shape question. Okay. That's not bad. Now, what you'll notice about the rest of it is that there's a symmetry. So as we solve one side, we'll solve the other. And we're going to use our compass bit, so I'm going to solve as I go. Makes it a bit easier, a bit faster. What do we know? What do we know? So let's give ourselves some points. I really should go that 5, but look, that's 5, that's 6, and that's 7. Okay, completely out of order, but hey, these things evolve as they come. So that's 6 there, and that's 3. Well, let's think about it. Where could 5 be? And a lot of the time we're going to combine two pieces of information. Do I have the true length? Okay, this is your question of the day. Do I have the true length? Let's hope that doesn't overlap with this drawing. Anyway, I do, because look, there's 6 up there, 5. It's a horizontal line, so the true length is in plan. So I have the true length. Now, remember all that work we did back with Loki back in beginning? Well, this is where it comes into play. 5 is somewhere along that line. Okay, so that curve is a collection of all the points that are the distance 6 to 5 away from 6. So I have one piece of information about 5. What else do I have? Well, do I know how far it is from 3? Yes, I do. That's the true length there, from 3 to 5. So let's go and measure that. There we go. And now I know where 5 is. Okay, so that is how you solve this one. And this is probably something we haven't done as much, but you can see how it builds on everything we've done before. The true length from 6 to 5 is on this curve. The true length from 3 to 5 is on this curve, and that's where they intersect. All right, I got the first true length from the plan, because I know that's horizontal. I can see it there. And I got the second true length from 3 to 5 from the earlier part of the question. Okay, what else do we know? Let's begin to just keep moving. So actually, while we have that done, let's do the other one here. So I really should have done the first curve while I had it, but hey, I was distracted giving you guys words of wisdom. Of course, that is symmetrical. So there's our other point. And show those little arcs, okay? That way you're proving that you got it. Let's go over to 7, see can we get it. 5 to 7, is that a true length? No, because sloping down, that's not a true length in plan. However, it is an elevation. As I look straight at it, there to there, it is a true length. Okay, so that's a true length to 7. There we go, somewhere over there. What else do I have? Well, I could do my diagonal trick from 6, but that does look a little bit hard work, so I'm going to see can I avoid it. I'm wondering can I come from 3, just to make life a bit easier. Okay, so that is true length from 5. From 3, can I see a true length? Well, I can, because 3 to 7, there's 7 there, is on the ground. So that's a true length. But before I do that, we're going to put a little arc in this side. Remember, we're doing this symmetrically. Okay. There we go. 3 to 7. Look at that. Now we're getting better at symmetry, and we're just going to drop it in as we go. So this one here is the true length from 3 to 7. And you can see that was a fair bit easier than getting the true length from 6 to 7, which would have completely worked. But you know, we like the easy way when we can do it. There we are. There we are. Now, I've made a little bit of a mistake earlier on because I forgot that these are dotted lines. I had a sheer habit. So I'll go back and fix that. But I'm remembering it now. And if you're wondering how I'm remembering, as I go, I'm kind of cross-checking back and forth with this just to see does this make some general sense. And I spotted the lines. Okay, so we'll go back and fix this in a little moment. This one here, we'll take the T-square out of the way. Okay, that's an exterior line. This is an interior fold. So we'll put that in as a dashed line. And now we should go and fix this little wobble here. Okay, so the last little bit we've got is those tabs on the top. So while I'm fixing this, you guys go have a peek and see, can you see the true length we might need or any other information. So what have we got? Well, we know as we look down the rectangular. That's kind of handy. I also have a true length from there to there. Okay, so I'll do it over on this side and we'll copy it back because it looks like I might just end up overlapping. So that's a true length. It's a fiddly small annoying true length, but hey, we've actually had a fairly nice run in this question so far. There we go. And you'll notice it's going to be the same here. Now just be a little bit careful because that arc, of course, is from the previous part of the drawing. So we'll just make sure we're not setting ourselves up for confusion. Well, what do we know about this? We know it's a rectangle, so we can actually use our perpendiculars. I'll do it this way just so you can see the shadow will be better on it. Okay, there we go. So we can just take a perpendicular line. If I didn't do that or spot that, what I'd end up doing is getting the diagonal on it. That, like we said, is hard work, so we won't do it when we don't have to do it. Works like that quite nicely. And again, as I'm thinking about this one, a slightly easier way to have done that would have been to, now we'll rub out this arc just so we don't have confusion. Throw out that perpendicular first, then mark the point. Okay, I only actually need one. Okay, you'll see why, because I can just come straight across from here, straight up from 5, completely planned that, barely touching the L, yes, and now I have it all. Okay, so that is my development of it. Okay, working with diagonals, arcs all the time to figure out what information do I know. I know that 7 is somewhere along that line, the true length from 3. I know it's somewhere along this arc here, true length from 5, and therefore there's only one place. Okay, now at this stage you're flying, you're 41 marks. They often throw the last little bit in as just a little bit of a twist in it. Openings are 60mm offset from the outside edges of the surface, so we want them in the plan and in the elevation. Right, okay, they're going to make us work for this a little bit. So I'm going to see this in the development. Okay, and again, my usual hint is look back to the last thing. What's that hint? 60mm is 10mm. Okay, so this we can draw. It's fiddly, but it's fairly fast. Now, here's how I'm going to do this. And this is worth noting if you don't, I have to do it up here first, I think, so you can see it properly on camera. If you haven't done this before, it is worth paying attention to this little bit here. All right. What I've got is I need to move this edge by 10. Okay. I'm going to line up this with the line. It's very hard to see this edge, so I'm going to line up my 0 and my 10. See them right there and there? And now I'll just slide that down to 9. I know the 45-degree set square has moved by 10mm. Happy days. Let's go down and get the bottom piece at the same time because they're nearly aligned, so we'll set that up there. We slide that up by 10. There we go. Okay. And repeat and repeat. Now you'll also notice you could do a certain amount of projecting across if you wish to as well, because it's symmetrical. Now let's go get our next one. Okay, this actually will be slightly easier to do like this. There's one part of the opening. Reset that and come back. And finally down here. So I can see the rest of that opening there. We'll get that in place. Okay, now, how do we put this together in the development? Well, here's the way I'll have a look at this, okay? I need to know all these kind of indents, but they're no longer 10 mil. However, what can I see? So let's come back to true lengths, okay? All about true lengths. I know this distance from here to here, and this distance from here to here, which is probably the same actually. Okay, and I can see them up here. So let's set my compass and measure that. Are they the same? They are the same. So there we go. That distance there and that distance there. So that is the distance that we see it come in. Okay, we'll call it D1 because I suspect I'll need a different one later on. D1 as well. Okay, D1, D1. Now, what that tells me, because we want to keep ourselves projecting and keep solving the rest of it, is that the bottom is along there and the top is along there. All right. Okay, because if I do a horizontal line along there and a horizontal line here, that's where the bottom is. That's my horizontal line. Now, okay, that's cool. I got these two. Can I do anything about these guys here? Well, can I do my same trick? How much has it pulled in? A little bit. And certainly I can see a true length here. So let's just extend that. Show you what I mean. I extend this line here. I can see this distance. Okay, we'll call that D2 across the bottom. Well, let's go find that. So D2 from 7. Get you a better little arc there. And we'll do the same on the other side because it's quickest to do these symmetrically at the same time. And one really important DCG fact to know is that if we have lines that are parallel in one view, they're parallel in every view. So there's D2, there's D2. So this line here, which brings us up to the edge of it, is parallel to 5, 7. Okay, so it's parallel in all of these. Grand, off we go. Okay, we just pop that in heavy while we're here, and we'll do the exact same over here. Do be careful, once you get into these very tight angles, mistakes get magnified. Okay, so now we're flying, same issue, we're going to get another one down here. Okay, so as we look at this here, find that distance there. That's going to be different distance because it's different angle. That's D4. Okay, again, 3 to 7 is a true length in the plan. Okay, ooh, I need to be careful, don't I? Because that was not a true length in the elevation, so that's all wrong. Excellent. So we'll go back and fix that in a moment. All right. We need to be a little bit careful on this here. Yeah, my apologies. You start getting ahead of yourselves. That's of course not a true length, is it? It's down here. That's where we see the true length. So go back and fix all that up here. That was G2. There we go. There won't be much in it, but there will be a little bit in it. Okay, this is D2. And now we project up and find it here. You can see it is a little bit off. There we go. And now we do it properly. There we have it. Okay, so small but important difference. Okay, don't be worried about making these mistakes. I would normally assume that little mistakes will happen, and the thing is we're kind of cross-checking ourselves as we go along the way. So now we have that. What else are we going to have? Well, I can do the same concept of bringing stuff down from there. Okay. And we can come back across this way. All right, well, we'll do that in a little moment. Let's go and get the last bit of this one here. So we need to figure out how far to come in. And actually, this one's nice because look, we can do this on the drawing. Okay, can we do it? No, we can't do it on the drawing. So we need to figure out our D4 here. D4 is there. Okay, that's D4, and that's a true length of D4 because this is the true length here, D4 and D4. Project up, solve, project back. Okay, and actually that can go the whole way up there, that's quite nice. We have that, that. Now I'm just going to go around and solve this. And sometimes what I started doing before was bring it down, but of course it can get a little bit confusing as to which line you're going down to. And sometimes it's easier to fully solve it in one view. Then you can kind of see where you're at. All right. We know that's on a line here. What do we know about this line here? Well, the handiest way to do it is to look out to the edge. That is the sloping line here, which is this line here, which is this point, and we'll come back. Okay, so that's that line there. And just because things are getting a little bit busy and probably tight on time, we'll just send that straight across, and we can do it again. See the way we can just shortcut things a little bit by using the symmetry that's in this. Okay, so I have this line, I have this line. I'd love to know where these guys go up to. So what do I have here? I have that line. Let's come down to there. Okay, so we'll bring this guy down to here. And now we can come back and we'll get that top connection. And we'll just mirror that across. So that came from here. And we get this top connection. Again, there's probably loads of ways to do this, and you may even see a slightly more elegant way to do it, in which case, happy days. Now I'm just going to draw in the bit I have here, which is this section here, just to help you see where I'm going. The last bit I need to know is how far out from that line. Now, what can we get on this one? We can find what we have, D2, and that's parallel to this edge, so actually it's straight across. There it is. Okay. There we go. We'll just send that guy straight across. Right, so that last bit was actually fairly hard, but they often do that in DCGs. They do make you earn the H1s. If you didn't get to that last bit, you're 41 out of 45 marks, so you're absolutely flying, okay? But there is some nice little bit of thinking, okay? You would have quite possibly gotten this bit, okay? We see this fairly regularly. These were the tricky bits, how we can see true lengths and apply them in different situations.